This video uses a simple example to explain how Hamming code works for correcting single mistake in a 10-digit number. Let's say we have a number like this. Then after transmission, it is read as this. Somehow mistake happened. There is one mistake here. 1 is read as 7. In order to correct this error, we need to know two things. First, we need to know the position of error. Secondly, we need to know, we call it error magnitude. In this case, error position is 3, error magnitude is 6. When we find the position here, we need to bring 7 back to 1, right? So 7 need to take away 6, which is this error magnitude, and get back to the correct value. Just need to mention one thing here. For binary numbers, when we do error correction, we don't need to know anything with error magnitude, because with binary, only two values. So if we know it's wrong, we just go there to flip the value. 0 will be 1, 1 will be 0. In this case, we're dealing with decimal numbers. So we do need this error magnitude. Now I will explain how we can make it work. Our first 8 digits, the real data, random data. Then we will generate 2 actual check digits. When we add check digit, we must follow these 2 conditions, such that all the 10 digits add together, mod 11 must be 0. And then you add them together again, this time add weight on each digit, and they should be 0 as well. Therefore, both simple sum, which is this one, and the weighted sum, which is this one, mod 11 must be 0. So we need to add D9 and D10 to make these 2 equations hold. You probably want to ask why we need these 2 equations and how to generate a D9 and D10 to make these 2 equations hold. I will talk about why, then explain how. Here is our 10-digit number ready to be sent out. And let's have a look what happened before transmission. And we know our 10-digit number must satisfy this condition. Simple sum must be 0. And similarly for weighted sum, we get 0 as well. It's guaranteed because we carefully generate a D9 and D10 such that these 2 conditions hold. Then after we transmit data, we do same calculation again. Let's call it S1 and S2. And they got nice name. We call them syndromes. Syndrome 1 and syndrome 2. So if both syndrome 1 and 2 are 0, that will meet our precondition. Then we know everything is perfect. Let's assume we have a single mistake. Something we added here, say it's a value k. And that k must reflect here, right? Because this is equation, which means S1 will correctly represent error magnitude. In our previous example, if you remember, should be 1, but we have 7, right? That equivalent, what we did is in this formula, we added actual 6. We added 6 more in the equation. Well, all the correct value will be down to 0, so 6 will represent here. Now, how about error position? That will rely on my second equation. Because every item here is weighted, so for example, if at position 3, if you made a mistake, and then you will have 7 times position, this is a 3's position, okay, as opposed to 1 times 3. So 1 times 3 is a correct value, but we got 7 times 3. So therefore, really, we get one actual multiplication here, which is 6 times 3. The result of x2 represent the error magnitude, which is, we represent the k, yeah, times position. Then we know S1 is k, S2 equals, we substitute this by S1, So S1 times position. We know this is constant value, that's another constant value. So we can get unique answer for error position. I summarize here. Error position times syndrome 1 mode 11 should be our S2. Therefore, if I can move S1 to the other side, that would be the error position can be worked out by using S2 divided by S1. Okay, you can see by calculating two syndromes, then we can find out what is error magnitude and what is error position. Job is done. Let me explain how to generate D9 and D10. We know the precondition is these two given equations. Then from D1 to D8, they're all given values, which means constants. Only D9 and D10 are variables. We need to work out how to calculate both D9 and D10 from given 8 input. The first step, let's add equation 1 and 2 together. You can see when we add together, you get D1 plus D1. Therefore, we get 2D1 here, right? So this is 2D2 and add one more. We have a weighted sum, and each one will add one more because that is simple sum. The result of adding 1 and 2 will get basically each item get one more. 2, as opposed to 1 we get 2, and the 2 here we get 3. Yeah, in the end, last one 10 we get is 11. So every term got one more. After we add them, we notice the very last item changed to 11 times D10. Then we know 11 mod 11 is 0. So therefore, this item is cancelled out. D10 times 11 no longer exists in the equation. We got this one, so let's label it as 3. Now, we move the last item to right side. Then we know anything moved to the other side will be minus, yeah? So 10 times D9 now change to minus 10 times D9. We know under modulo 11, minus 10 equals 1, right? So this one should change to D9 instead, minus 10, right? So we just simply copy it, this to here, and write down whole thing properly. You can see that's how we calculate the D9. Our next step is to work out D10. So we already know what is D9. Yeah, this is D9's formula we just work out. We can substitute D9's value into this, our first formula. So we copy this, and when we get D9, we substitute this whole lot's value, right? So that is the result after substitute. It's quite long, so I put a dot there. So this is just copy. After merge, you get 3D1, so everything increment by 1. Compare with our previous value, yeah? So finally, the D10 is only D10 himself. The next step is easy. We just simply move everything else. We just move everything else to the other side. So which is this whole lot thing. Apart from D10, we move to the other side. Everything you move to the other side will be negative. So then this will be minus 3 D1 here. And this will be minus 4 D2. But because under module 11, we change minus 3 to 8. Yeah, we change to minus 4 to 7. Therefore, the final solution is this. That's the answer we're looking for. We got what D10 is. This summarizes two formulas, how to calculate D9 and D10. And during error correction step, we use these two formulas to work out two syndromes, and then we check the syndrome value to detect either there is error or not. If there is error, S1 will represent error magnitude, and S2 divided by S1 will represent error position. Let's use the example I gave you at the very beginning of this video to work through all those calculations. We have 8 digits, consists of 8 ones. Now, this is a formula to work out D9 and D10, yeah? Let's substitute those values as all 1. So that will end up with 44 mod 11. Then we know result should be 0. Now, secondly, if we replace them by 1 again, the result should be 36. 36 more 11, result is 3. Therefore, we generate a code of 10 digits long with 0 and 3 in the end. Suppose this 10-digit number transmitted with a single error, so we can see the error occurred here. Let's just go through step by step, see how we calculate two syndromes. S1, as you remember, is a simple sum of everything. So let's count 1, 2, 3, 4, 5, 6, 7 ones makes 7 plus that 7 plus 3 makes 17. Then 17 mod 11 makes 6. Therefore, we can see the calculation here, S1 equals 6 is correct. And S2 is every value have to times their weight. So it will be 1 plus 2 plus 7 times 3 is 21 plus 4 plus 5 plus 6 plus 7 plus 8, and then we plus 30. The result for that should be 84 if you verify yourself. Then 84 mod 11, what's that? Is 7. So now we check that that value is also correct. Then we know the error magnitude will be represented by S1. Therefore, error magnitude is 6. Which is correct. You look at here, yeah, error magnitude is 6. Then error position is worked out by looking at position, we don't know what is. Then we know position times error magnitude, in this case is 6, should be 7 under modular 11. So we can quickly tell what's number here. Times 6 make it 7 under modular 11. Answer is 3, because 3 times 6 makes 18. Then 18 mod 11 equals 7. Now the conclusion is that we have error at position 3, the magnitude is 6. Hope that you enjoyed learning this Hamming code. Thank you very much for watching.